Hey, we are finding derivatives and we're focusing on higher order derivatives. That means second derivative, third derivative, and so on. But we're going to be finding the second derivative, and we've got y is equal to x squared over 3 minus the natural log of x. So we take the derivative of x squared over 3 first, and so the derivative of x squared, bring the 2 out front, and of course I'm just going to rewrite the denominator here, and then subtracting 1 from the exponent, that leaves us with a 1, and the derivative of the natural log of x, which I covered in some earlier sections, which you might want to check out if you don't know how to take the derivative of the natural log of x. But the way this goes is you just take the derivative of what's in parentheses, and the derivative of x is 1, and then whatever's in parentheses you just rewrite it down here in the denominator. Now what I'm going to do here before I take the second derivative, I'm going to take this x and take it up into the numerator, so this becomes x to the negative 1. This has a power of 1, but we bring it up and it becomes a negative 1. Okay, properties of exponents. Now we're going to go ahead and take the derivative again. So we take the derivative of 2/3 x, and the derivative of 2/3 x is just 2/3. We want to take this negative 1, bring it out front, subtract 1 from the negative 1, you get negative 2, and then of course we clean all this up and we end up with 2/3 plus 1 over x squared. Now I didn't get this all into one single fraction, I just left it like this. So anyway, if you want to get it into one single fraction, you do that. Alright, we got f of x equal to x squared log base 3 of x, and we're going to end up finding the third derivative, I think, in this problem. Let's take the first derivative. We got to take the derivative of x squared, which is 2x, rewriting the second function, plus rewrite the first function, and then the derivative of x is 1. We rewrite what's in parentheses, but then down here we have to put the natural log of the base, which happens to be 3. And so I clean this up a little bit, rewriting it. And now we want to take the second derivative. So we're going to be using the product rule here. And so the derivative of 2x is 2. And then I rewrite the second function, plus rewriting 2x, and then taking the derivative of log 3 with log base 3 of x. And so that means you take the derivative of x, which is 1, and rewrite what's in parentheses here, and then the natural log of 3, natural log of the base down here, plus, and then we take the derivative of this guy and it just becomes 1 over the natural log of 3. And it looks like I just cleaned it up a little bit. We have an x down here and x up here, so they cancel out, so we have 2 over the natural log of 3 plus 1 over the natural log of 3. Okay, now we want to take the third derivative. Now instead of writing 3 primes up here, I just write a number 3, which indicates we need to take the third derivative. Okay, so we got 2 constants right here, so we know that we take the derivative of both these constants, they just fall out, they're just 0. So we want to take the derivative of 2 log base 3 of x, so that means we're going to rewrite the 2, and we take the derivative of what's in parentheses, what's derivative of x? 1. Then we rewrite what's in parentheses down here, and this time we write the natural log of the base of 3. And so that's going to be the third derivative. So that's not too bad. Okay, but let me just mention something here real quick. You might have forgotten how to take derivatives of log functions, but if this were a natural log, remember, I wasn't writing the natural log of e, because the natural log has base e. So we don't write it down here because the natural log of e is just 1. So that's the reason you haven't been seeing me write this like we did in an earlier problem where this was the natural log function. But this the log function has base 3, so we have to write the natural log of 3. Alright, that's all I wanted to add to that.